Hello everyone, this is Suvendu Sir, your physics mentor, and welcome to our lecture number 10 of our chapter light of that is reflection and refraction available in class 10 CBSE physics. And up to lecture number 9, we have discussed reflection in a very detailed manner. In that portion, we have discussed what is mirror, what is image, and different types of mirrors, spherical mirrors and its types, ray diagrams involved in spherical mirrors, magnification, and related numericals we have discussed in a very detailed manner. So, in this lecture number 10, we are going to start our topic refraction of light. Okay, so with full of patience, try to listen it properly. Okay, without any delay, starts our content. So, first thing is, what is the meaning of refraction of light? First, we have to discuss what is the meaning of refraction of light. Remember, when light travels from one transparent medium to another transparent medium, तो क्या होगा? Then change in the direction of path of light rays can be observed in general. In some special cases, the change in direction of path of light rays we can observe. Okay, so remove that special case from your mind. So listen properly. When light ray travels from one transparent medium to another transparent medium, then the direction of change in path of light rays is observed, and this phenomenon of light is called refraction of light. So in this refraction, तो हमको पता चल रहा है एक्चुअली इन केस ऑफ रिफ्रैक्शन मीडियम चेंजेस, बट इन केस ऑफ रिफ्लेक्शन मीडियम रिमेन्स सेम. दैट्स द बेसिक डिफरेंस बिटवीन रिफ्लेक्शन एंड रिफ्रैक्शन. यहाँ पे मीडियम कंपल्सरी चेंज हो. So in case of meaning of refraction of light, in first point what we have to write, we have to write the phenomenon of change in the direction of path of light rays when it travels from or when it passes from one transparent medium to one transparent homogeneous medium. Homo means same, geneous means mixture. One transparent homogeneous medium to another transparent homogeneous medium. It's called refraction of light. Think it is clear to all of you? Called refraction of. And remember, the direction of path of light rays, okay, starts to change when it enters in the second medium. And suppose remember, listen, ये हमारा एक bottle, and inside this bottle or beaker, water is present up to this level. Above the water क्या है? Air is present. ये जो surface अभी तुमको दिखाई दे रहा है, ये वाला जो surface, actually this surface separates two media. This surface separates two media. ऊपर क्या है हमारा air, नीचे क्या है water. तो इस surface को हम लोग मानेंगे interface. We call it as interface. Interface means surface separating two media. Surface that separates two media. तो interface का meaning क्या है? Surface that separates two media. My question is, why the direction of light ray changes when it enters in one medium from another medium? Answer is due to change in speed of light. So in second point what we have to write, the change in direction, the change in direction of path of light ray occurs due to change in speed of light. And further question is, why speed of light changes when it goes from one medium to another medium? The answer is due to different optical density of medium. The next point is due to different optical density of medium. Densities of media. Speed of light starts to change. Speed of light to change. I think it is clear to all of you. So next come to our content, that is optically rarer and optically denser medium. So in our third point we have discussed, due to different optical densities of the medium, speed of light changes. So what do you mean by optical density? Now see, what is optical density? So remember, it generally refers to the speed of light in a medium. Speed of light in a medium. Okay? Yes. So optical density को ऐसे समझो, the amount of obstacles available in the path of light. So if I will say, if optical density of a medium is low, if optical density of a medium is low, then what we can assign? Then speed of light in that medium क्या होगा? Optical density low, that means amount of obstacle क्या होगा? Yes. Its speed of light in that medium is speed of light in that medium is high, and particularly this type of medium को हम लोग बोलेंगे, this medium this type of medium is called optically rarer medium, called optically rarer medium. These are called optically rarer. तो ऑप्टिकल डेंसिटी एंड स्पीड ऑफ लाइट देखो, ये लो होगा तो ये हाई होगा, तो ऑप्टिकल डेंसिटी हाई होगा तो स्पीड ऑफ लाइट क्या होगा? लेस होगा. तो रिमेंबर, ऑप्टिकल डेंसिटी एंड स्पीड ऑफ लाइट इज इनवर्सली प्रोपोर्शनल टू ईच अदर. सो यहाँ पे हमको लिखना चाहिए ऑप्टिकल डेंसिटी is directly proportional to 1 by speed of light. Or directly you can say optical density is inversely proportional to speed of light in the medium. I think it is clear. Then उसका opposite point क्या लिखना चाहिए हमको? If optical density of a medium, if optical density of a medium is high, then speed of light in that medium will be less. Speed of light in that medium is less. And remember, this type of medium is called optically denser medium. This type of medium called optically denser medium. Optically denser medium. In a very fruitful manner, is clear to all of you? Okay. तो देखा जाए तो एयर एंड वाटर के बीच में, इन बिटवीन एयर एंड वाटर, we can say air is optically rarer medium and water is optically denser medium. So what will happen when light ray travels from optically rarer medium to optically denser medium, and when light ray travels from optically denser medium to optically rarer medium? Let's see. Next is our when light ray travels from optically rarer medium to optically denser. तो ये जो दिखाई दे रहा है रेड कलर लाइन, ये देखो यहाँ पे ऊपर क्या है? मीडियम 1, Let us consider this is your rarer medium and नीचे क्या है medium, that is our denser medium. Okay, now this dotted line is our normal. This ray is your incident ray AO. तो एंगल बिटवीन नॉर्मल एंड इंसिडेंट रे क्या होगा, एंगल ऑफ इंसिडेंस. यानी रेड कलर लाइन क्या हो रहा है, इंटरफेस. दिस इज द सरफेस सेपरेटिंग टू मीडिया. एंड ओ से लेकर बी क्या होगा, रिफ्रैक्टेड. डायग्राम को देखो तो दिस इज नॉर्मल, दिस इज रिफ्रैक्टेड रे, द एंगल बिटवीन देम इज आर, दैट इज एंगल ऑफ रिफ्रैक्शन. क्या दिखाई दे रहा है, व्हेन लाइट ट्रैवल्स फ्रॉम रेयर मीडियम टू डेंसर मीडियम. तो डेंसर मीडियम में एंट्री होने से क्या होगा, स्पीड ऑफ लाइट चेंज, दैट मींस स्पीड ऑफ लाइट डिक्रीज. ऑन बिहाफ ऑफ दिस refracted ray bends towards the north. Refracted ray bends towards the north. So this line, this dotted line represents direction of incident ray. So incident ray wants to travel in straight line path. This is your direction of OB. ये क्या शो कर रहा है, refracted ray. Listen, ये देखो ये जो लाइट रे उसका ओरिजिनल पाथ से कितना एंगल डेविएट हो गया, दिस वन. दिस एंगल इज कॉल्ड एंगल ऑफ डेविएशन, एल, एंगल ऑफ डेविएशन. So with this maximum information are available in this diagram. One more thing, this line and जो normal, these are intersecting each other. ये एंगल आई होगा तो ये टोटल एंगल कितना होगा, ये होगा. डेल का वैल्यू क्या होगा, एंगल आई माइनस एंगल. तो यहाँ पे कौन सा एंगल ग्रेटर है, एंगल आई इज ग्रेटर देन एंगल आर, आज रिफ्रैक्टेड रे बेंड्स टुवर्ड्स द नॉर्थ. So in note point what we have to write here, refracted ray bend towards the normal, towards the normal. Then second point, angle I is greater than, angle I is greater than angle R. नेक्स्ट पॉइंट क्या मिल रहा है देखो, देन एंगल ऑफ डेविएशन डेल इक्वल टू ग्रेटर एंगल माइनस लेसर एंगल. और क्या चीज देखो डायग्राम पे, इन डायग्राम और इन फिगर, फिगर AO is our incident ray, very good, and OB, that is our refracted ray. Next, O is the point of incidence, O is the point of incidence, perfect. And NON dash, NON dash क्या है, normal, NON dash is our normal. And angle I क्या है रे बोलो, angle I is angle of incidence, angle of incidence, and angle R is our angle of refraction. So this is about case when light travels from optically rarer to optically denser medium. Happen. Okay, is it clear to all of you? Next, come to our next content. When light travels from optically denser to optically rarer medium. तो यहाँ पे देखो, this is medium 1, that means denser medium. Then this is medium 2, one is rarer medium. rarer medium में एंट्री होने से स्पीड ऑफ लाइट इंक्रीज होगा. So this is A, point is O, this is B, A O incident ray, O B refracted ray, angle between N O N dash is normal, angle between incident ray and normal is angle of incidence, angle between refracted and normal is called angle of refraction. This dotted line represents direction of incidence, direction of ray, and this light ray wants to travel in this straight line path. तो ये एंगल आई होगा तो ये एंगल कितना होगा, आई होगा. तो दिस डायरेक्शन ऑफ इंसिडेंट रे से ये जो ओरिजिनल पाथ से कितना एंगल भटक गया, देखो डेविएट हो गया, इज द एंगल. ओके, तो एंगल बिटवीन डायरेक्शन ऑफ इंसिडेंट रे एंड रिफ्रैक्टेड रे कॉल्ड एंगल ऑफ डेविएशन, परफेक्ट. So in note point, what we have to mention? Simply we have to mention here refracted ray. Refracted ray moves away from normal, moves away from normal. Second thing, angle I is less than angle R, or we can write angle R is greater than angle I. What is angle of deviation? Is greater angle minus lesser angle. So this thing you will observe when light travels from optically denser medium to optically rarer medium or denser to rarer medium. So in between, for example, when light passes from water to air, water to, but when light travels from, for example, air to water, when light ray travels from air to water, you may see this case. And when light travels from water to air, I think it is very clear to all of you. So this is about light that travels from optically rarer and optical rarer to optical denser, denser to rarer. Then a special case we will discuss. Here you see this represents our interface, surface separating two media, and above the interface medium 1 is present, suppose, and below the interface medium 2 is present, and this dotted line represents your normal, this represents your incident ray. That means incident ray falls perpendicular to the interface. Falls perpendicular to interface. So angle between incident ray and normal, both are showing same line. So angle I will be equal to, and in this case the refracted ray travels in the second medium without any bending. Remember, so this is your refracted ray also. This one is refracted ray and it is your normal. So angle between them will be angle R, that is also, and there will be no deviation. Original path of light rays and refracted ray coincide with each other. Angle of deviation will be 0, and we can write here refracted ray passes or travels in the second medium, travels in medium 2 without any bending, without any bending. Bending nature cannot be observed, but remember, still it is called refraction. But still it is called refraction. For refraction for general definition, we have mentioned the phenomenon of change in direction of path of light rays. But I have mentioned one thing: in case of refraction, medium must change. So as medium changes in this case, as medium changes, still it is called refraction. So this is about our light ray falls perpendicular to the interface. Particularly in this case, we can observe the bending nature. But remember, this is a special case of refraction. I think it is clear to all of you. So next come to our summary. When light ray travels from rarer to denser होने से क्या हो रहा है? Angle I is greater than angle I, and refracted ray bends towards normal. हो गया? Bends towards. Second thing क्या है देखो? When light ray travels from denser to rarer, so in this case angle R is greater than angle I. So refracted ray moves away from normal. Okay. Next क्या है देखो? Oblique incidence. Very good. Oblique incidence का meaning क्या है? Suppose this is your interface. Suppose this is interface and this is your normal. And ये तुम्हारा incident ray होगा तो this is normal, this is incident ray. तो ये जो angle दिखाई दे रहा है, this angle is greater than 90, but less than 90 and greater than 0. तो ये इंसिडेंट होगा तो इस टाइप का इंसिडेंट देखो, ये जो भी हमको दिखाई दे रहा है ना, ये सब कुछ ऑब्लिक इंसिडेंस. इन केस ऑफ ऑब्लिक इंसिडेंस एंगल आई is less than 90 degree but greater than 0 degree, and here change in direction of path of light rays observed. Direction of path of light rays can be perfect. Then light ray incidence normally. This is called normal incidence. This is called normal incidence, and in this case, light rays travel without any bending. Without any नेक्स्ट केस क्या है देखो एंगल ऑफ इंसिडेंस क्या है हमको पता है एंगल बिटवीन दिस द एंगल बिटवीन इंसिडेंट रे एंड नॉर्मल इंसिडेंट रे एंड नॉर्मल and what is angle of refraction? It is the angle between refracted ray and normal refracted ray, and this is about the summary that we have discussed in our previous slides. Okay, so with this we have completed the basic concepts related to our what refraction of light. Now come to observed phenomena due to refraction of light. Okay, this part is completely interesting. So first is a coin at the bottom of a bucket filled with water appears to be raised. So without the water, the coin का position क्या है देखो यहाँ. So after the filling of water in the beaker, so what you will observe, the coin appears to be raised due to refraction of light. So this is the fact. Next is our another example. Letter printed on the page of a book appears to be raised when seen through a glass placed over it. देखो ये लेटर का साइज जनरली जो भी है उसमें भी वही था, लेकिन as we are observing from this side and a glass slab is present on the letter, उसका साइज क्या दिखाई दे रहा है, थोड़ा रेज दिखाई दे रहा है. रेज मीन्स थोड़ा बड़ा दिखाई दे रहा है तुमको, बस दैट इज हैपनिंग ड्यू टू रिफ्रैक्शन ऑफ लाइट. नेक्स्ट इज ए पेंसिल partly immersed in water in a glass appears to be bent. ये तो बहुत सिंपल सा एक्सपेरिमेंट यू कैन परफॉर्म इन योर होम. ओके देखो पेंसिल, okay, with the presence of water due to refraction it appears to be bent. Next, egg in a glass filled with water appears to be bigger than its actual size. तो जितना उसका साइज है ओरिजिनल साइज थोड़ा सा बड़ा दिखाई देगा ग्लास फिल्ड वाटर के अंदर उसको इमर्ज करने से. तो दिस इज हैपनिंग बिकॉज ऑफ रिफ्रैक्शन आल्सो. ओके, so with this we have completed our refraction content का जो first lecture. Okay, we know this is our lecture number 10, but in lecture number 10 we have started our refraction topic. So starting from the meaning, and we have completed up to our observed phenomenon. In next part we will discuss laws of refraction, Snell's law, refractive index, etc. Stay tuned for next update. Thank you and have a nice day.